Hi, Saffron. It's Miss Yam. How are you? I hope that you are doing well in Maryland, I think is what you said. And, on the chance that you come to campus next year sometime, please make sure you come and say hello. I'm thinking about you and hope that you are finding some rest and relaxation this summer and that you're filling your time next year in a way that you want to. So I thought the easy thing to do here was just to go through your exam so you can see it. Question number 1 was very well done. You took care of finding the net sign volume where I told you to use cross sections in certain directions very well. This was all correct. All this number 1 was correct. So no problems there at all. And I like part C when you found this, the middle point and asked you to figure out where an absolute max would exist. That was the correct reasoning right here because the area is significantly greater below your value of R than it is above your value of R. Okay, number 2, all good. Part A, you were asked to just find the level curves at z equals -2, z equals 0, z equals 8. Those were all very well done. Then here you found del F at this point A and this point B. Just some minor notation here. Be careful. You had dx by df. F is the dependent variable. X is the independent variable. So these should be df dy and df dx. Okay. And then I did check and you saw here your gradients are right here. That was all correct. Now this one, part C. Okay. So look at part C. Part C on question number 2 asked you to do the following. It asked you to, give me a second here. So it said, find parametric equations of a line that is tangent to the level curve, okay? Not normal. So what you did, you used this point 1, 6, you found del z, you plugged in 1, 6 for del c. That would then give you the vector normal to the curve, not tangent. In other words, this vector here, when you input in 1, 6, would be this vector. It would be normal to your level curve. I wanted the curve to be tangent, the line to be tangent. And because you know that a normal and tangent line are perpendicular, the vector you're looking for, I just happen to call it vector u. The vector you're looking for is one such that u dot 4, 1, and 4, 1 would be your del z here. U dotted with 4, 1 should equal 0. Okay, so that was one error with part C. And if you want to print out this my grading, you'll notice that where there's green, I made the corrections. Okay, 3, I think, what you wrote here was fine. I think it's not necessarily completely clear to me in your description that you recognize this was just a plane, okay? And you could have found where the plane intersects the 3 axes to get a sense of the plane's orientation. But again, what you wrote here is not wrong. Notation again for defining del F, these should be df by dx and df by dy. Okay, part C. So here I wanted you to find an equation for a line that let me go back. This one was asking for, let's just be clear. Yes. Given your starting point of 2, -1, f of 2, -1, if you were to travel 5 units in the direction of max rate of change, where would you end up? Okay, so you're correct that you want to take your starting point, which is right here, 2, -1, 4. Okay, what you want to add 5 of, you want to add 5 of these gradients unitized because the gradient points in the direction of max rate of change. So what you want to do here is unitize 3, 2 and then add 5 of those. And that will land you in the location that is 5 units away from the point 2, -1, 4 in the direction of 3, 2. The vector that you unitized, it looks like you took just the first 2 coordinates of the position right over here and you unitized that. And so this, you're heading in this direction is what you're doing here. And this direction is not the direction of max rate of change. This is the direction of max rate of change. Okay. Question number 4 is the optimization question. You were asked to find the dimensions of the box, which you labeled as X, Y, and Z, that would have the minimum cost given a volume of 12, okay? The one pretty important step that you forgot here was to incorporate the constraint of volume. So this equation here is correct in that this is your cost function. This is the function that needs to be optimized, in this case, minimized. What you need to then incorporate into this is this equation here, 12 equals X times Y times Z. You could have solved this for either of any of these three variables and then input that by substitution into the cost function. This would then yield you a cost function that's a function of two variables, which you would then go through the steps to find the extrema within the extrema within the domain region. Okay, does that make sense? So the part that you forgot here, and I can see here you kind of got yourself a little stuck. The part that you forgot to do was to incorporate the constraint, and then you go about finding the partial derivatives, and then you can use the second partials test for extrema. Okay? Okay, number 5, let's see, the wart problem. Oh yes, this was kind of a fan favorite. Parts A and B were great. A asked you to find dW by dZ. You did that correctly, and the significance was correct. dW by dt, correct use of the chain rule here. I know this got a little messy, but you hung in there and did it well, and you got your way to the end. Very good. Yes, odd situation. You have a situation where dW by dt is undefined and your interpretation was correct. Okay, part C, it said which independent variable, and the independent variables here are X, Y, and Z, right? And if you remembered X, Y, and Z, okay, X, Y, and Z are number of hot dogs eaten, number of yaks in your backyard, and the number of ounces of your toe. So the question's asking you which of these three variables should you manipulate in order to get a handle on your wart growth problem. And getting a handle on it means you want to, obviously, I mean, no one wants to have warts growing. You want to minimize it, right? So you found the three partial derivatives correctly, but then look what you said. You said because this rate of increase is greatest. Well, if this rate of increase is greatest, isn't that a bad thing? Like you would, if this rate of increase, first of all, it's the rate of increase. So no matter what you do, how you manipulate Y, you're going to be increasing the number of warts. However, if you look at this dW by dZ, especially this negative right here, that this dW by dZ, the warts will start to decrease with the increase of your toe size. And look where the independent variable Z is as opposed to the independent variable of Y over here. Do you see how, first of all, the dW by dZ is negative. Do you see how the Z value being squared in the denominator will get this rate to 0 very, very quickly? I think perhaps what you may have been kind of thinking about is the fact that because dW by dy is most positive here, if I could manipulate y, then that would have the greatest impact on the rate of change, right? And I can see your logic there. However, I think it's still overridden by the fact that if you compare these three rates, there is one variable, namely your Z value here, that does create a situation where you want to be, which is that where your warts are decreasing in number. This was a relatively minor deduction though, Sev, so that's not too concerning to me. Okay, this was a limit question. This was saying show that this limit here does not exist. And the first thing you did here, which is what you do in calculus for the limit question, you just kind of subbed in these points and you found you had 0 over 0. Be careful, I see you wrote an undefined here. 0 over 0 means the limit is indeterminate. It could be undefined, but this alone does not allow you to conclude undefined, so it's indeterminate. You said I'm going to approach the point 1, 1 from the curve y equals 2x. But what I said to you here was, that should be a but y equals 2x does not pass through 1, 1. So the curve that you want to pick, in terms of how you are approaching the point in question 1, 1, it has to be a point that passes through 1, 1. So I think the linear curve y equals x would have been the easiest to work with. And then you want to pick a second curve. And again, y equals negative 2x does not pass through 1, 1. I think an easy curve would have been y equals x squared. And we had talked about in class, just when you think about the curves through which to pass the point in question, to think about your kind of simplest linear function and your simplest quadratic function. And usually in those two, and also the constant functions, which here you did not do, like x equals 1 or y equals 1. Once you kind of work through those three, the constant, linear, and quadratic, you'll either have some kind of discrepancy or confirmation in those three attempts. Okay, so that was a difficult question for you, I could tell. And number 7, this was all correct. 7, if you recall, was looking at this contour plot, and you were asked to then determine the sign, or whether that it can be determined, of these partials and second partials and mixed partials, and you were all correct here. Okay, so at the end of the day, I would look at this exam, and I would say that this exam here would be a B+/A-. And for this, I went and looked at how I graded the other exams for your classmates, and I'm going to give you an A- for this exam, Severin, okay? And then what I'll do is I will send an interim with a note saying that you are officially and finally conclusively done with your senior year math requirements, and I'll have the final grade on there as well, which I believe will be an A, but I'm going to double check that. So it was a pleasure, Severin, and I know this was a difficult year for you. It was a pleasure nonetheless. I wish you the very best, and I do hope that you please come by the math office and say hello if you're ever on campus. Take care.